Hey Confluence Crew, I'm Chantel, the AmeriCorps Education and Monitoring Technician at Palouse Conservation District. And today we're along Union Flat Creek where I'm going to be demonstrating once-a-year assessments. The data you collect will help us so much in letting citizens learn more about the water quality as well as help us implement more water conservation projects throughout the Palouse. We ask that all volunteers complete a once-yearly habitat assessment to collect additional site information that is very valuable in assessing overall site health. These assessments include a habitat assessment, which you will conduct midsummer, a stream flow assessment, and a nutrient and bacterial test, which will be conducted each fall. The fall test will require additional materials that can be checked out by any monitors in good standing. You can schedule a time to pick up these additional items from our office. We have limited kits available, so we ask that when you conduct your fall assessment, you return the kits as soon as possible so that we can pass them on to the next people in need. The Midsummer Habitat Assessment will need to be conducted during July or August. This assessment will be pretty simple. All you will need is the Habitat Assessment form, which you can follow along and then calculate your final score.
You will need to conduct the stream flow assessment in September or October. Once the fall precipitation events have started to occur, the streams are carrying more water. Stream flow is the amount of water per unit of time flowing past a given point. We will be calculating the water flow based on the area of the stream and the speed of flow as it travels along the stream segment. Please be sure to conduct the stream flow assessment at the same time as you conduct all your normal monitoring activities. First, let's go through the additional items you will need for the stream flow assessment. A measuring tape, a tennis ball or orange peels, a stopwatch, a depth stick. Now let's measure out a 20-foot segment of the stream.
Step 1 is to measure 20 feet of your stream. Here you can see that I've already measured out 20 feet. I'm standing at transect 2, which will be downstream, and transect 1 will be upstream. If you do not have 20 feet of your stream to measure, that is okay. Just make sure you record the distance that you do have. Step 2 is measuring the width and the depth of the stream. As you can see here, I have placed my measuring tape along the width of the stream at transect 1. And I just want to make note that you want to put marker places where transect 1 and 2 are, because you're going to be using the same measuring tape to measure the width. You're going to be using this measuring stick to measure the depth at least 7 times across the width of the stream, unless your stream is 4 feet or less. You're going to have your buddy record these numbers onto your sheet, and you're going to be calculating the average stream depth. You are going to repeat these steps at transect 2. And then on your data sheet, you're going to take the area from both transect 1 and transect 2 to find the average cross-sectional area and record this number on your sheet. Next, we're going to be measuring the speed of the stream. You're going to want 1 volunteer slightly upstream from transect 1 and 1 volunteer slightly downstream from transect 2. To find the speed of the water, position 1 volunteer slightly upstream of transect 1 and 1 volunteer slightly past transect 2. The first volunteer will drop the rubber ball into the swiftest part of the current, slightly upstream of transect 1. Once the ball reaches transect 1, the first volunteer will begin the timer on the stopwatch. Timing stops as soon as the ball floats past transect 2. The second volunteer will catch the ball. Repeat this process 3 times and find the average time per second from where the rubber ball passed transect 1 to transect 2. If you are sampling alone, it is okay to use an orange peel, as this does not need to be retrieved. Step 6 is to choose a correction factor. 0.8 is for rocky bottoms and 0.9 is for muddy bottoms. Record this answer on your data sheet. Step 7, refer to your data sheet so you can calculate the flow. If you are uncomfortable entering the water, please refer back to the Confluence Crew handbook for alternative methods on how to measure the stream flow. For the nutrient and bacteria testing, PCD staff will contact you ahead of time to remind you of this testing and give you a time in which it will need to be completed. You will need to check out a test kit containing sample bottles. Each bottle will have a label and a tag on it with a blank spot for you to fill out the date and time the sample was collected. You can consult the Confluence Crew handbook for instructions on how to complete the sampling process. We will have all of our Confluence Crew members complete this testing within the same time frame, so that we can ship out all these fantastic water samples to the lab. The results will be reported back to you so that you can see the data on your water quality for yourself. Thanks for following along. If you have any questions about the once-a-year habitat assessments, be sure to review the Confluence Crew handbook. The handbook contains more information that will help you interpret the conditions you're seeing at your site. You can also reach out to PCD staff with any questions. We appreciate your help in our research of the waters along the Palouse.